Hi guys, Matt here with MonsterVR again. Back for another C# lesson. Just to let you know, right now I'm just teaching out of this book called Learning C# Programming with Unity 3D, written by Alex Okita. And doing small little projects. I hope these videos are getting better, or at least better quality, or maybe my teaching. I don't know. I'm really just teaching myself. Hopefully you guys pick up something that maybe I don't. But anyway, all right. Today we're going to go through class scope and see what that is. Got a couple little projects, a little bit more code, but we got function scope as well. Actually, you know what? Yeah, we'll probably run function scope today too. It's not too bad. Okay, cool. So let's get started. Let's go to Unity, Mono Develop. Boom. There we go. Now let's get started. Okay. Encapsulation is the term given to where data can be accessed from. The amount of accessibility is called scope. The visibility of a variable to your logic changes depending on where it appears. Encapsulation can hide or change the accessibility of data between statements, functions, and classes. Another way to think about it is keeping data on a need-to-know basis. This invisibility is intended for several reasons. One reason is to reduce the chances of reusing variable names. So what we're going to do is we're going to start off with, in the start function, we're going to put a for loop in. For, boom, boom. Zero. I is greater than 10. I plus. Cool. Get that right there. And we'll open that with curly brace. Bam. Cool. And we'll just do print I. Bam. Okay. For this example, we use the print function. Thanks to a long history of programming, almost every language has some version of print. This function does the same thing as debug.log, but it just means less typing. There are often many ways to achieve the same result. It's just up to you to pick which one to use. Cool. I'm going to turn on this fan over here. It's a little warm. All right. So basically, this would probably print I, I'm assuming. Control S. Go back to here. We're going to put class scope on the main camera. Cool. Let's go to the console and hit play and see what happens. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bam. Printed 10. Perfect. All right. So let's go to the next thing. Class scope. And Unity. There you go. Cool. To get a better look at how scope and encapsulation work together, we're going to work with the Scope Unity project. That is a project that you can download. I believe real quick, I'll just show you. These where you can get all the projects. GitHub right here, you can download them. Hopefully you can see that. If not, I will post it in the comments. I'll start doing that from now on, actually. I'll just post that in the comments. Okay. So let's go back. Class scope. So we're going to work scope Unity project. I'm not going to do that. I'm just going to code it out myself. Attached to the camera is the scope Unity project, which can be found in the downloaded materials provided. When the scene is run, the code attached to the camera will execute as normal. So we are going to create a class. We'll actually take this one, go to Assets, Create, New C# Script. I'll call this one, actually, you know what? We're good with this. I don't think we need to. Yeah, I don't need that. We should be good with this one. So we'll go here. To there. Close that guy off. Cool. Alright. So we'll do int my int cool. Equal to 1 semicolon. Perfect. And then the void start function. Cool. What happened there? Yeah. Cool. So let's do debug.log my int. Cool. See what happens. Control S. That's already got that on there. Let's hit play. Console. Hold on, let's try that again. 1. Cool. That worked out. I'm going to turn on the fan. Way better. Cool. All right. A little cooler in here now. All right. So the my int variable exists at the class scope level. My int can be used in any function that lives in the class scope. The example code you're looking at will produce the following console output, which is 1. You see right here. Boop. Both start a function and update function live in the class scope, so both can see the my integer variable. Therefore, the following code will send a 1 to the console. Both start function and update functions will keep sending 1s to the console window. So, so we're going to go into the update function now. And we're going to put a d.log parentheses, and we'll go my int as well. Perfect. Cool. Let's see what happens. Aha, there we go. So it's collapsed. So it should be spitting out 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, because in the update function, so it's just spitting it out every frame. Cool. So that's how that works. Let's go back to the final develop. Placement of a variable at the class scope has little effect on where it is used. The code above can be ranged rearranged easily, the code below will behave exactly the same way as the code above. Oh, so basically if you... This is bugging me a little bit. No, whatever. Blah, blah, blah. So if we basically did this, took this variable, and we cut it, and we put it right here, this will basically do the exact same thing. But I am curious, so let's run it. We'll clear. We'll hit play. There it goes, doing the exact same thing. So it doesn't matter where, but I think for organization purposes, it's always good. It's always good practice to keep your variables in one spot. I mean, at least through my experience. So let's go ahead and get rid of that, and we'll put that right back there. Boop. Cool. So, the functions and variables act in the same way, irrespective of where they appear in the class. However, class scope is easy to override with other variables of the same name. This is called variable collision, the effects of which you should be aware of as discussed in section 7, which we're not there yet. So, we go... Let's try this. So we go public int my int is equal to 1, and then in the void we'll get rid of this debug log here, and we'll get rid of this one here, and we're going to put integer. Oh no, we're going to do a public integer my integer is equal to 2, and then we're going to go I know this thing's already hating my guts for this. It's funny. I can't even, like, I'm trying to fool it already and it's still not, like, no. No. Why don't you like this? Int my int is equal to oh, it's she doesn't like the public. Got it. There we go. Alright, let's try that. See what happens. Two. Ah, got it. I see what happened. So when you do that, when you declare a variable here and you declare a variable in the function overrides this. So that's why it's once you have it declared, you can't declare it again unless you want it overridden, supposedly. So that's good to know. All right. If we declare a variable of the same name in more than one place, then it will be overridden by the closest version of our variable. If you were to run this script in your scene, you'd have the console print out 2 because of the line that preceded the print function call. There are problems with how variables can collide with one another, and the best way to avoid this problem would be to come up with good names for your variables. Therefore, we can use both versions of myInt. Oh, that's a question. Therefore, can we use both versions of myInt? Let's try public int myInt. So let's go here. I'm going to take this, Control C, So I wonder what's going to happen here. Close this off, and we should be good to go. Control S. So basically what we're doing is we just added a line, but we'll see what happens when we hit the play button. I have no, oh, it already throws an error. My int cannot be used before it is declared. Consider renaming the local variable when it hides the field. Right there. Let's click on that. It's going to load it in MonsterVR. And as you can see, there's the error. Boop. The answer is no. The result of such a declaration will be an error. Local variable myInt cannot be used before it is declared. You may have expected the first print function to print out the class scope version of myInt, but this isn't the case. The variables that live at the class scope happen to still exist even if you stomp on their name with the variables of the same name in a function. The keyword this preceding the variable unhides the variable that is living at the class scope. So, if we did debug.log and we added this dot myInt, I have no idea what will happen, but we shall see. Let's go Control S. We'll hit clear. Alright, we're not throwing any errors. And play. So we got 1 and 2. Let's see why. By creating an int myInt inside the start function in your class, you have effectively hidden the class scoped myInt from the function. Although it can be accessed as this dot myInt, the myInt in the function takes precedent. Let's go back to here. So this, because it has this one takes function. Let's read this again. By creating an integer myInt inside of the start function in your class, you have effectively hidden the class scoped myInt from the function. Although it can be accessed as this dot myInt, the myInt in the function takes precedent. Because got it. So it's still saying print out my integer, which is 1, and then do this. But do this first. Print this 1, and then print that one, basically. Cool. This example should also highlight that a variable can be used only after it's been in... am I in the right spot? Yes. Okay. Well, this example should also highlight that a variable can be used only after it's been initialized. This is a situation best avoided, so it's good to remember what variable names you've used so you don't use them again. To elaborate, a function starts from the first curly brace and computes one line at a time, working its way from the top, moving toward the bottom till it hits the closing curly brace. If a variable is used, but if a statement uses a variable before it's declared, an error will result. To elaborate, a function starts from the first curly brace and computes one line at a time, working its way from the top, moving toward the bottom until it hits the closing curly braces. If a variable is used, but if a statement uses a variable before it's declared, an error results. Got it. So let's do this. Let's go debug.log myInt is equal to 3. Control S. Go back to Unity. My int cannot be used before it's declared. Consider renaming the local variable when it's class scope my int. Something that might be obvious but should be mentioned is the fact that you can't reuse a variable name, even if the second variable is a different type. We will get the following error in MonsterVR explaining our error. My int is used before it's declared. Consider renaming the local variable when it hides the field. Yep. Another effect of creating a variable inside of a function is the fact that another function can't see what's going on. In the following code, we declare a start int in a function. After that, we try to use it again in the update function, which results in an error. So, let's try that. So we go into the start. We're going to call this one start int. Print my personal int. Okay, it's not even liking that right now. In the update function, we'll go print doesn't like that either. Let's see what happens. Oh, it's still gotta control. Let's try saving this. Let's see what errors. Oh, look at that. The name start int does not exist in the current context. Yep, it does not work. So, and obviously, we knew this wasn't going to work because this is bold red. And usually that means stuff is not working. C# is telling us that we can't use a variable before it's declared. Of course, we did declare it once, but that was in a different function. The update function can't see inside of the start function to find the myPersonalInt created in the start function. You have to keep in mind, once you start writing your own functions, there are two common ways to work with declaring variables. The first is to place all your variables at the top of the function. This way you ensure that everything you may need to use is already declared before you need them. The second method is to declare the variable just before it is needed. So, in this next function, we're going to go and we're going to get rid of this one. Second int, and we'll call that one 200. Oh, not S100, 200. Perfect. And then we'll go print my first int. And print my second int. Cool. Let's get rid of this. Control. Oh, I don't have a closing break, so I'm not closing the parenthesis. There we go. Bam. Control S. Go back to Unity. Let's clear. Good. We're not running any errors. Let's hit play. 100 then 200. Cool. That worked. Let's try it the other way. It says, in this case, we're being very clear inside of the function about what variables we may use. For short functions, this can sometimes be a lot easier to deal with. You can easily sort your variables and change their values in one place. It's also easier to check if you're accidentally using a variable's name. So the other way to do it, it would be here, Control X, Enter, Control V. Alright, Control S. Let's see what happens. I think it's the same thing, but we shall see. And we did that. Cool. In the second case, we're using the variable only after it's created. When writing long functions, you may find the second method a bit more clear, as you can group the variables together near the logic and functions that will be using them. This is a small example of code style, but when reading someone else's code, you'll have to figure out how they think. In some cases, it's best to try to match the style of existing code. However, when you're writing everything on your own, it's best to keep your own style and decide how you want to arrange your code. If we declare a variable at the class scope, all functions inside of the class can see and access the variable. Once inside of a function, any new variables that are declared are visible only to that function. Some statements can declare variables as well, and those variables are visible only inside of the statement they are declared. Once we get to know about more statements, we'll see how they work, but we'll need to keep scope in mind when we get there. So, interesting. That's class scope. So next we're going to do, I think we're going to do some quick function scope, and then we'll be done. Pull up some MonsterVR. Alright, function scope. Variables often live in an ephemeral life. Ephemeral life. Okay, I'm going to spell this word. Ephemeral life is the context. Ephemeral. That's exactly how you spell it. Please, if you know the meaning of this word, put it in the comment section. That'd be fantastic, because I have no idea what that is. That's why I have it underlined. Anyway. Some variables exist only over a few lines of code. Variables may come into existence only for the moment a function starts and then disappear when the function is done. Variables in the class scope exist for as long as the class exists. The life of the variable depends on where it's created. In a previous exercise, we focused on declaring variables and showing them in the Unity's 3D inspector panel. Then we observed when variables need to be declared to be used without any errors. The placement and public keywords were necessary to expose the variables to the Unity 3D editor. The public keyword can be used only at the class scope. This is called class scope, as the variable is visible to all the functions found within the class. Making the variable public means that any other class that can see this class can then also have access to the variable as well. We'll go into more detail on what that means and how it is used later. Adding the public int within the start function will produce an error. Yes, as we saw, you are not allowed to elevate a variable to the class scope from inside of a function. MonsterVR will inform you of the error. Unexpected symbol, public. The reason is that variables within a function cannot be made accessible outside of the function. There are systems in C# to make data within a function accessible, but using the keyword public is not it. We'll look into how that's done in section 6.1. A variable declared inside of a function exists only as the function is used. The variables declared at the top of a function are declared at the function scope. This is to say that the variable is visible to any statement within the function. So we go to the start function and we just do this, right? Control S. We all know what this is going to produce. Let's get rid of that. Control S. So let's hit clear, and we'll hit play. Boom. Prints out 100. Right? Cool. If a function declaring int start int, I did my first int, it's the same thing, is valid, but its scope is limited to within the function. No other functions can see or directly interact with my first int. So like update can't use this function here because it is broken, or it's not broken, it just can't see it, because if it's declared in here, it's blind to the rest of the classes and functions. There are methods to allow interaction within the function, but we'll get into that in section 6.3. Function declared in the class. The functions declared in the class are also a part of the class scope and at the same level as the variables declared at the class scope level. If a function in a class is preceded by the public keyword, it's accessible by name, just like a variable. Without the public keyword, the function will remain hidden. We'll make use of public functions in chapter 6, but it's important to note that a function can be made publicly available like variables. That is true. So if we wanted to, we'd go, and I don't know if you could do a public starts function, but like you would do like public, and then if you wanted to say like if this was like my function, then now I can use that with other scripts or with other classes, and other things can see this function. Cool. Referring to the scope it's actually class scope.cs because that's mine. We're going to make use of the functions given to us by the programmers in Unity 3D. The location of a variable in code changes where it can be seen from and how it can be used. As noted, limiting accessibility of any variable is called encapsulation. The curly braces and parentheses have a specific context. This context can keep their contents hidden from other sections of code. This means the start function can have one value for start integer, and if you create a new start integer in update function, it will not be affected by the start int in start function. So if we did int, I'm going to call this class int, boom. Oh, that is a public class, but int is not. And we're going to go call this the start function again. Start. And we'll go let's get rid of this. Go int start int, and in the update we'll do int update int. I don't know any of this thing, what it is going to do. Control S, make clear, play. It's going to do anything. Nope. Does nothing. Alright, let's read on. Okay. If we look at the above figure, we can visualize how scope is divided. The outer box represents who can see. So right here, so if you assume like this is like encapsulated, it says if we look at the above figure, we can see how scope is divided. The outer box represents the class integer. So this, what you could do is you could put this here if you wanted to. And you could say that this box is the box called class scope. Within the start function, we have a start and that only exists within the start function. So this right here only exists within the start function. This only exists within the update function. But the update function and the start function are in this box called class scope. So within the start function, we have a start integer that only exists within the start function. The same is repeated for the update integer, found only in the update function. This means that start function can use class integer and start integer, but not update integer. Likewise, update function and can see class integer and update integer, but not start integer. In the diagram below, the boxes represent different levels of scope. So we're going to do something a little funky here. I have the first level of Star Fox in my head for some reason. Cool. And we're going to go, so we're going to hit these curly braces here. So once these curly braces are here, we are now running a function within a function called a for loop. I don't know if that's a function necessarily. Maybe it is. I don't know. But it definitely looks like it's encapsulated and separated from the start function right here. So if we did integer start int bam, and then we did debug dot log we'll go either. Whoa, what the, that's cool. Yeah, that's funny. Debug.log I. And then in the update function, we're going to do keep the update int, but we're going to do the same thing. Control Z. My puppy's barking. Control V. Oh, whoa, whoa, whoa. Control Z. Control C. Control V. It's the exact same. Yeah, it's the exact same thing. Oh my gosh. I tab. That is a weird thing it keeps doing. I don't know how hilarious. Okay. So this is what they have us here. So it looks like these for loops here are also encapsulation, these curly braces. Within each function lies a simple for loop. We'll go into more detail about how our for loop works, but in short, for loops create and use their own variables which have limited scope and exist only within the confines of the loop. This also means that the for loop inside of the start function has access to class integer as well as start integer. Following the same restrictions, the for loop inside of update can see class integer and update integer, but not start integer here or integer I, which exists in the for loop that's been written in the start function. Crazy. I wonder what happens when we hit play. It didn't even explain anything with that. Let's just do it anyway, see what happens. Oh, nothing. Oh, there we go. Did run 2 errors here. Hold on, let's hit clear. Hit clear. Hit play. No errors, but it is doing 1, 2, 3, 4, 1. That's in the update function. Hit collapse. Oh, it's for looping. Crazy. It's over and over and over and over again. Crazy. Okay, cool. Okay, we're at the end. So what have we learned? Well, encapsulation describes a system by which a variable's scope is defined. Depending on where a variable is declared, the scope of the variable changes. Encapsulation prevents variables from overlapping when they are used. Encapsulation therefore allows one function to operate independently from another function without needing to worry about a variable's name being used. We'll cover more situations where scope becomes a useful tool to help classes message one another. Encapsulation and scope define a major principle of object-oriented programming, and understanding this concept is important to learning how to write C#. So encapsulation and scope. I highly recommend to get to know more of these about these concepts and terms, because it seems like they're very important when it comes to writing this stuff. So anyway, that's the end of our lesson today. Once again, my name is Matt, and I'm with MonsterVR, and every day, you know, learning a new thing, at least getting 1% better, right? Anyway, thank you guys for watching, and any feedback, please put in the comments below. Awesome. Later.